Hello again. We're going to be looking at problem number 2 found on page 261 of your geometry textbook. This is in lesson 4-6. And we're going to write a proof using the hypotenuse leg theorem. And if you look carefully, we're given that BE bisects AD at point C. And we know that AD is perpendicular to BC. And that DE is perpendicular to ED, and we're also given that AB is going to be congruent to DE. Now all these are marked in the picture already. Because AB is perpendicular to BC, we have these right angles here because that's what perpendicular means. We also have tick marks that AB is congruent to DE. We have the tick mark here and the tick mark here to denote that. Now, if we're trying to prove that these two triangles are congruent, again, we start with our given. We know that angle ABC and DEC are right angles because of the definition of perpendicular lines. If these are perpendicular, then those two angles, of course, are going to be congruent to each other. They're going to be right angles because of the definition of what perpendicular means. And then finally, we also know, again, AB, I don't really like the way they've spread this out, but AB and DE, that was again already given. Here's the one we have to kind of figure out on our own, and that is that AC is going to be congruent to DC, which is this right here and this right here. And that comes from this statement right here, that BE bisects AD. By definition of bisector, bisector means it splits AD in half, or splits it into two equal parts. And that's why we know that those two parts are going to be congruent, is by the definition of bisector here. So if we know that, then again, this is the hypotenuse of the triangle, and this is the leg of the triangle. And of course, it has to be a right triangle, which we established that it was. And so because of that, we can say that these two triangles are congruent to each other, again, by the hypotenuse leg theorem, which is what this particular section or lesson is really all about. Okay, so let me move this down a little bit, and let's look at the got it section. If we were given that CD is congruent to AE, which again is marked here in the picture for us, and that AD is perpendicular bisector to CE, that means that this is going to split CE in half, and it's going to be perpendicular to it. So remember, if that's going to be a right angle, then this also is going to be a right angle, because vertical angles, of course, are going to be congruent. And then, as we look at this, we also know by again, just for this same reason as we did right here, that CB is going to be congruent to BE. That right there is going to be congruent to that, because of this statement right here that AD is the bisector of CE. And by definition of bisector, we know that it splits it perfectly in half. So that's why we can say that CB is congruent to BE here, is by definition of bisector. And again, we have the hypotenuse of a triangle, of a right triangle, and a leg of a right triangle. So these two triangles really are congruent to each other, again, by the hypotenuse leg theorem. Okay? So when you have a right triangle, it's actually pretty simple to prove that the triangles are congruent to each other, because there's just two things that you actually have to prove. And usually one of those is already given to you. So it makes for an easy proof when we're using hypotenuse leg theorem. But please remember that this only applies for right triangles. It doesn't work for just any triangle. Specifically, it has to work for right triangles. I hope this was helpful.